Hello and welcome to your Algebra 2, Lesson 6.4. Today we're going to use inverse functions, so you will find inverse functions and you will use them. Let's take care of some definitions. An inverse relation is a relation that interchanges the input and output values of the original relation. This means that the domain and range are also interchanged. So if the original relation is the set of points 1, 2, 3, 4, 5, 6, then the inverse relation is a set of points 2, 1, 4, 3, 6, 5. So the x's and y's have just been interchanged. The graph of the inverse relation is a reflection of the graph of the original relation across the line y equals x. To find the inverse of a relation given by an equation in x and y, switch the roles of x and y. Okay, so we're going to find an inverse relation given as an equation. So we want to find the inverse of y equals 3x minus 5. So we're going to write the original relation. And then we're going to switch x and y. So we're going to rewrite it as x equals 3y minus 5. After that, you just solve for y. So you're going to add 5 to each side, giving you x plus 5 equals 3y. And then we're going to divide by 3. And in that, we will be solving for y. And so if I divide both sides by 3, I get x plus 5 over 3, or if I apply that divided by 3 term-wise, that understood 1x becomes 1 divided by 3, so 1/3 x plus 5 divided by 3, so 5/3. So this is the inverse relation, y equals 1/3 x plus 5/3. When both the original relation and its inverse are functions, they are called inverse functions. Functions f and g are inverses of each other, provided that f of g of x equals x and g of f of x equals x. In other words, you take x and you put it into one of the functions, and then you take that result and put it into the other one, you end up back at x. One function undoes what the other function does. The function g is denoted f inverse and is read just like I said, f inverse. Verify that f of x equals 3x minus 5 and f inverse of x equals 1/3 x plus 5/3 are inverse functions. So there's two steps to this. Step 1, we're going to show that f of f inverse of x is equal to x. In other words, when you take f inverse and you plug it into f, you should end up with x. So f of f inverse means that we're going to have f of, and here's the rule for f inverse, 1/3 x plus 5/3. So this is going to be our input into f. All right, f is 3 times input minus 5. So we're going to have 3 times 1/3 x plus 5/3 minus 5. So now we want to distribute that 3. 3 times 1/3 is just 1, so we have 1x, which we just write as x, plus 3 times 5/3 is 5, and then our minus 5. Well, x plus 5 minus 5 is x. Now, for step 2, we're going to go in the opposite direction. In other words, we're going to show that f inverse of f of x is equal to x. So this time, f of x is going to be our input into f inverse. Okay, so f of x has a rule of 3x minus 5. So f inverse of f of x is equal to f inverse evaluated with the input 3x minus 5. Okay, so looking at f inverse, everywhere we have x, everywhere we take in an input, we're going to put the whole expression 3x minus 5. So we're going to have 1/3 from our inverse rule times our input, which is 3x minus 5, plus 5/3. Okay, so for this one, I need to distribute the 1/3. 1/3 times 3 is just 1, so we just have 1x, or just plain old x, minus 1/3 times 5 is 5/3, plus 5/3. And so x minus 5/3 plus 5/3 gets us back to x. So we have verified by showing those two steps that f of x and f inverse of x are indeed inverses. Okay, we want to find the inverse of f of x equals x squared for x greater than or equal to 0. So we're restricting our domain of f. Our range of f inverse is going to have to mirror that. So we're going to have to restrict our function values to being greater than or equal to 0. So we've got f of x equals x squared. We're going to replace f of x with y just because it makes it easier while we're finding the inverse. So we've got y equals x squared. Now we're going to switch x and y. So we're going to have x equals y squared, and we're going to solve for y. So we take the square root of each side, and we get y equals plus or minus square root of x. But the domain of f is restricted to non-negative values of x. X has to be greater than or equal to 0. So the range of f inverse must also be restricted to non-negative values, 0 or larger. Therefore, the inverse is just f of x equals square root of x. Okay, we reject the possibility of y equaling negative square root of x because the range of the inverse has to match the domain of the original. So if the domain had been restricted to x less than or equal to 0, you would choose f inverse equals negative square root of x. Okay, you want the range of your inverse to match the domain of your original. So here we have our little picture. If you need to today, use your CAS to help you with these. Next lesson, we're going to really talk about graphing square roots and cube roots. Okay, so f of x equals x squared. You should know what that looks like. We're just interested in x greater than or equal to 0, so we just have 1/2 of the parabola of y equals x squared. This is the half that's for positive value, or non-negative, values of x, because we are including 0 also. Square root of x, we have square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. The next one we'd have on there, square root of 9 is 3 for integer values, and so we draw in f inverse of x equals square root of x. Now, to tell whether or not the inverse of a function f is also a function, you need to do the horizontal line test. We did the vertical line test to tell whether a relation is a function. Now we're going to use the horizontal line test to make a statement about the inverse. So for this little function here, because the horizontal line intersects the graph no more than once, any horizontal line, then we have a function. But if a horizontal line ever can cross your original function twice, then the inverse is not a function. Okay, so the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once, which is the case right here. But over here we've shown an example of a horizontal line that does cross more than once. So for this function, its inverse is not a function. Consider the function f of x equals 2x cubed plus 1. Determine whether the inverse of f is a function, then find its inverse. So use your CAS to help you and look at f of x equals 2x cubed plus 1. Draw it on the graph. Okay. You can also make a little table. If we plug in -1, we'll get, for x, we'll get -2 plus 1, which is -1. If we plug in 0, we'll get 2 times 0 is 0 plus 1, which is 1. If we plug in 1, 1 cubed is 1 times 2 is 2, plus 1 is 3. So here we have 1, 3. And then just sketch this in. I really suggest using your CAS. Next time we will be working with graphs in a little more detail. We're going to graph the function f. Notice that no horizontal line intersects the graph more than once. You can draw all the horizontal lines you want, and you're never going to cross this function more than one time. So that means that its inverse is also a function. So we're going to write the original function, f of x equals 2x cubed plus 1. And then we're going to replace f of x with y. So y equals 2x cubed plus 1. And we're going to switch x and y. So we're going to have x equals 2y cubed plus 1. That way when we solve for y, we've got the inverse function. So we subtract 1 because we're solving for y. And so we get x minus 1 equals 2y cubed. Now the next step to solve for y is divide by 2. So we get x minus 1 over 2 equals y cubed. And then the last step is to take the cube root of each side. So we get the cube root of the whole thing, x minus 1 over 2, that over 2 is inside the cube root as well, equals y. So the inverse of f is f inverse of x equals cube root of x minus 1 over 2. Okay, that's it for this lesson. Thank you to Larson Algebra 2 and Hope McDougall for making all these wonderful resources available. Do the problems to try on your own and have them ready for class next time. And I will see you then. Have a good day. Goodbye.